charge, which talks about additive nature, conservation, quantization, where I have taught you what is the meaning of additive nature, what is the meaning of conservation, what is the meaning of quantization, and how the questions are asked from these topics. Additive nature is something where the charges are scalar quantity, they are algebraically added. Net charge on a body is the algebraic addition of individual charges. Conservation is charges cannot be created, charges cannot be destroyed, it is just transferred from one body to another body. If a charge, that is negative charge, is transferred from one body to another body, then the body becomes positively charged, isn't it? And to the body on which the charge goes, the body becomes negatively charged. That I have taught to you in the previous sessions. Then I have talked to you about Coulomb's law, where I told you Coulomb's law is the electrostatic force of attraction or repulsion is directly proportional to the product of their charges and inversely proportional to the square of distance between them. F is equal to K Q1 Q2 by R square, where K is 1 by 4 pi epsilon naught. Epsilon naught is the permittivity of the free space, so electrostatic force is medium dependent force. If the medium is changing, epsilon will change. If it is for free space, it is epsilon naught. If it is some other medium, it will become epsilon, and the ratio of this forces is known as dielectric constant kappa or epsilon r relative permittivity. Many students are writing F is equal to K Q1 Q2 by R square, that K as dielectric constant. It is not so, it's wrong. Small k is not dielectric constant. Dielectric constant is kappa, which is the ratio of forces between the two charges when they are kept in free space to when they are kept in some medium. And when you solve, you will get epsilon r or k as epsilon by epsilon naught. When you solve, you will get this. Kappa is equal to epsilon r is equal to epsilon by epsilon naught. It means whenever epsilon naught is multiplied with dielectric constant or relative permittivity, you get permittivity of that medium, isn't it? So if I ask you, for a free space, what is the dielectric constant? Your answer will be 1. For free space, what is the dielectric constant? 1. That's why 1 is equal to epsilon by epsilon naught. You will get the value of epsilon as epsilon naught. Same way, for different mediums, you will have different dielectric constants, and when you multiply dielectric constant with absolute permittivity, which is also called as permittivity of free space, you get the permittivity of that medium. Beyond that, I told you about how to use Coulomb's law in vector form. When you have multiple charges, you have to use the knowledge of 11th to solve the vector form, where you will take the forces, directions, and then properly solve. That is a complex part of this chapter, which I have spent some time slowly giving worksheets to you, and if you have done it properly, by now you are knowing how to solve multiple charge questions. Charge in the center, charge in one corner, other forces, other charges, how they are applying force, I have taught to you in detail. If still doubts are there, you can come back to me and ask. Then I have talked about electric field. Electric field is force experienced per unit test charge if a test charge is placed in the region of another charge. Electric field is numerically equal to F by Q naught, where F is Newton, Q naught is Coulomb. So Newton per Coulomb is the SI unit of electric field. I have talked to you about electric field due to a single point charge whose formula is KQ by R square. It means if you have a charge Q and you want to find R distance away, what is electric field? Formula is KQ by R square. It means electric field is inversely proportional to square of distance. As you go away from a charge, electric field reduces. Then I have talked to you about what is electric dipole. I told you electric dipole is an arrangement of two charges equal and opposite separated by a small distance 2d, and strength of electric dipole is given by dipole moment, which is the multiplication of magnitude of charge times distance between them. Q into 2d gives you P, P vector. P is vector quantity, its SI unit is Coulomb meter. Then we talked about electric field due to electric dipole at an axial point and electric field due to electric dipole at an equatorial point. At an axial point, electric field is K, P. You are telling about the condition where R is much more than D. I am not asking about that condition. I am asking about general formula. General formula is electric field is equal to K into 2 PR by R square minus D square, the whole square. Mother formula, never forget it. If R is given much more than D, then yes, as you said, we can write E is equal to K into 2P by R cube, axial point. If it is equatorial point, then the electric field due to electric dipole is K into P by R square plus D square power 3 by 2. And if R is much more than D, then electric field is Kp by R cube. So for R much more than D condition only, electric field at axial point is 2 times electric field due to equatorial point. E axial is 2 times of E equatorial. These things are there in electric dipole. Derivations are very important. I have explained to you derivation. If you have understood the derivation, it is very simple derivation. But one thing to be remembered, electric field due to electric dipole at an axial point has the same direction as dipole moment. But electric field due to electric dipole at an equatorial point has opposite direction to dipole moment. That's why when deriving we are writing P cap and minus P cap in the case of equatorial point. After that, I have taught to you what is electric flux, which is before that I taught you torque actually, sorry. I taught you about the behavior of electric dipole placed in uniform electric field, and I told you it will experience a torque. Torque is Pe sin theta. That is, torque is the cross product of P vector and E vector. P is dipole moment vector, E is electric field vector. Okay. Then I have told to you that what is electric flux, which is dot product of electric field and area vector. Area vector is not area. Area vector is perpendicular drawn on any area. Very important point, because if there is a symmetric shape placed in the uniform electric field, electric flux becomes 0, because electric field lines entering, electric field lines exiting are same. That's why electric field is 0. So we even checked with one cube keeping, cylinder keeping in uniform electric field, we got the value as 0, isn't it? Then I talked to you about Gauss law. Gauss law is used to simplify the condition of finding the electric flux for a charge or given charges, and I said to you that Gauss law says that phi, which is equal to E dot dA, is also equal to 1 by epsilon naught times net charge enclosed. This I have told you in the previous class. Then by using Gauss law, after teaching that I taught you the charge distribution also. Linear charge distribution lambda, surface charge distribution sigma, and volume charge distribution rho. Charge per unit length is lambda, charge per unit area is sigma, charge per unit volume is rho. Then I have derived to you what is the electric field due to infinitely long charged straight wire. For that we took a cylindrical Gaussian surface, and then we found the electric field at point R. We got the value as lambda by 2 pi R epsilon naught, isn't it? So up to here we have seen the previous classes. I have revised almost 1 month of class. Whatever I have taught from last 1 month, I have revised in today's class. Now I am going to start with next topic, which is, give the heading as electric field due to infinitely spread charged sheet. Electric field due to infinitely spread charged sheet. Okay. I will do the derivation. I will give you time for copying. Okay. Till then, drop your pens, listen to me, understand derivation. This derivation is little complex, and it is more important compared to other two derivations. If you see last 5 years of questions of board examination, question has come from here only. Not only the derivation, numericals have come from here. So understand this logic very clearly. It is an important topic for the board examination. So please pay attention, everybody. Focus here. Right. So what I am going to do, I am going to take a sheet which is charged. I can take any charge, positive charge or negative charge, and here I have drawn a finite sheet, but I am doing this derivation for infinitely spread. So I don't have a finite area defined. It is not something like 10 meter square or 15 meter square. It can be even 1 meter square. It can be 1 million meter square also. So for a indefinite areas, infinite, that's why I am using the word infinitely spread. We don't have a restrictions that only small or big. Spread sheet is there. For that area, if I go r distance away from it, suppose if I go r distance away from it, then what is the electric field is my derivation. I want to find if I have a charge sheet, and for this charge sheet, if I am going r distance away, then what is my electric field? I hope you are understanding. So, suppose like this, there is a sheet, a charge sheet, right? And for this charge sheet, if I go some distance away, then what is the electric field at this point? That is my aim of finding. I hope it is clear to you. Charge sheet, I am going r distance away, and I am finding at this point what would be my electric field. I hope it is clear to you. Since it is a positively charged sheet, I hope you realize that the electric field produced by this positively charged sheet will be something like this, outwards in both directions. Do you agree with me or not?
Yes, sir.
Because positive charge has outward electric field. So, it will be outward in both sides. So, if this is the sheet, then the electric field will be how? You can hold it for Sana. So, electric field will be like this, isn't it? Coming out. If it would have been a negatively charged sheet, electric field would have been inward, into it, isn't it? So, I hope you have idea about how the electric field would be outward. It is not radially outward. Radially means in all directions. It is perpendicularly outwards. The nature of electric field is clear to everybody. Then my aim is to find the electric field at r distance away. What I can do, now the choice of Gaussian surface. Somebody can say, sir, I can take cuboid Gaussian surface. I can take cube Gaussian surface. I can do. There is no hard and fast rule in that. But I will tell you what I am going to do. First I will tell, then I explain why I choose that. I am going to take a cylinder having the length as this distance, and to make it symmetric, I will draw the same length in the opposite side also. Is it clear to you how the Gaussian surface is? Gaussian surface is cylindrical. Now you may say, sir, Gaussian surface should enclose all the charges. You are drawing a cylinder. This charge is left out, this charge is left out. So, how is it able to find the electric field of the whole sheet? Because some charges are left out. It may not find for the whole sheet, it may find for the sheet except these few charges which are outside the cylinder. You may have a thinking like that. But understand what I am trying to do. I am trying to find the electric field r distance away for a given area. Are you getting my point? My aim is not to find for the sheet now. I am restricting my thought to an area, because anyhow area is going to be a variable. It can be 1 meter square, 2 meter square, 10 meter square, 15 meter square, can be anything. So, if I find for this area, unit area, I can apply it to any area. I hope you are getting my point. So, my aim is to find what is the electric field r distance away for this area. So, I have assumed it to be a circular area. Okay. Now, first thing is, I have said you in all the three derivations, in the previous class I told this to you, in all the three derivations, what are the steps we are going to take? We are going to find flux by using normal derivation E dot ds. Then we are going to find flux by using Gauss law Q by epsilon naught. We will equate both and we will get the electric field. It is applicable to first derivation, second derivation and third derivation, all derivations. Last class also, if you remember, I have taken a wire, then I have drawn cylindrical Gaussian surface. I found phi is equal to E dot ds. Then I found phi is equal to Q by epsilon naught, equated both, got the answer as lambda by 2 pi r epsilon naught. Today, same logic. So, first of all, I know the electric field direction. I should know the area vectors also. Cylinder has three surfaces, right? This circle, and the curved surface area. Electric field is going something like this. So, if I talk about the area vectors, I am drawing three area vectors here. First area vector I am drawing like this, A cap, A1 cap. This I am drawing in this direction. This also should be same value, but I am writing A2 cap. And third area is curved area, A3 cap. Do you agree with me? This cylinder has three areas, one circle, back circle, and the curved surface area. Curved surface.
You mean the area vector?
I mean the area vector of all the three, isn't it? So, area vector is on this area I am drawing a perpendicular, anywhere you can draw. On this circular area I am drawing a perpendicular. On this circular area, I am drawing a perpendicular on this side. There are 3 area vectors here, for this surface, and for the curved surface. If you are understanding this concept, you will be realizing that this A3 is perpendicular to electric field, right? So the net flux phi, which is going to be equal to phi 1 plus phi 2 plus phi 3, in that phi 3 will become 0 because cos 90 will come. So for phi 1 it will become E A cos 0. Do you agree? What about phi 2? Very good, 180. Here also area and electric field is parallel. Unlike that case, that's why I asked this question itself. In that derivation, you are recalling, yeah, what you are recalling is there is an electric field existing. In this electric field, I am keeping a cube or a cylinder. Then yes, all electric field is in the same direction, so area vector is opposite. But here the electric field is like this, both directions. So here also cos 0. See, area, electric field parallel. Here also area, electric field parallel. Angle is 0 degree in both the cases. Am I right? So EA cos 0 plus EA cos 0 plus EA cos 90. Do you agree with me? I hope everybody accepts this. Any doubt? If there is no doubt, then I can write what is phi now. Phi became equal to 2 EA cos 0 is 1. So I got the value of phi. Let this be equation number 1. Also, by Gauss law, what we have? By Gauss law, we have phi is equal to Q by epsilon naught, Q net actually. Now what is Q net? In the case of surface charge distribution, sigma is equal to Q by A. So Q is equal to sigma into A. So can I write this as, that is phi is equal to sigma into A by epsilon naught, equation number 2. Do you agree? Now I am having from 1 and 2. So from 1 and 2, what do I get? Please pay attention. 2EA is equal to sigma A by epsilon naught. A gets cancelled. You get electric field is equal to sigma by, very, 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 very important. One strange thing happened here. You know what? There is no R here. So, if I am having a charge sheet, I am going this point, this point, this point, or this point, electric field remains same. That is why we are using charged sheets to create uniform electric field. I will come to this. If you have a single charge, 10 coulomb charge, 1 meter away, K into 10 by 1 square, electric field. 10 coulomb charge, 2 meter away, K into 10 by 4. 3 meter away, K into 10 by 9. It is reducing as you are going far. Non-uniform electric field. But if I am having a charge sheet, one direction, I am going to have all the places we are going to have same. But now my question to you is, can I use single plate to create uniform electric field? Answer is no. I will tell you why. But first, this is clear to you. The derivation is clear to you. If yes, take 2 minutes of time to write. Make it fast, please. Abhinand, woke up, man.
I joined.
Reasons you will never stop, I know. I will speak to you later. Man. You stay back after the class gets over, okay, Abhinand?
Sir, I don't have time, sir. Maybe my mother informed me. I have to leave early.
You are what he told? Today his birthday.
No. I thought my mother informed me. Like, I have to go home. School, they're taking us out in school.
Today you have to leave, you are saying.
Yeah. I'll leave by 9.
Oh, good escape. Fine, man. Enjoy.
I want to talk to you, sir. Anyways.
Oh, you want to talk to me? Good.
Yeah, sir. Anyways.
Okay.
I'll talk tomorrow degree, sir. Call you.
Yeah, call.
Also come to the.
Okay, enough, man. We are in live. You proceed. Copy. Which thing? Who told, man? I'll talk about that. 2 minutes to wait. Copy this, then I'll say you what is its practical possibility. Shall I proceed? Have you copied? No?
Yes, sir.
I'll wait for 2 more minutes. Make it fast, please.
This is, sir, small doubt, sir.
Make it fast. Please ask me.
The sigma is the charge density, right?
Yes, sigma is surface charge density. Correct. That's all. Abhinand?
Yeah, sir, that's all. That's my doubt, sir.
Okay, thank you. Now please pay attention. You get practicality of the derivation. I'll talk about that now. So I have a plate. Okay, I am drawing a single line because you imagine it is like this, right? If I ask you draw the diagram, what you will draw? Line only you will draw, no? Something like that. Okay, it is in this plane. So this is a positively charged plate. Okay. Then I am drawing another plate which is negatively charged plate. Clear to you? I have drawn a positively charged plate and I have drawn a negatively charged plate. Both are having same charge densities, that is, it is having plus sigma, it is having minus sigma. I hope it is clear to you what I have done. I have taken a plate plus sigma, another plate minus sigma. Let me draw the electric field produced by them. Lightest shade I will try to draw, should be visible to them also. Yeah. So positive means it will be going away from it. Am I right? I hope you are accepting the direction of electric field by the positive charge plate. Same way, any problem, man?
No, sir, I said yes, sir.
Very good. So negatively charged plate. Negatively charged plate, the direction of electric field will be something like this. Do you agree with me? Negatively charged plate, the electric field is towards the plate. Positively charged plate, the electric field is away from the plate. I hope you accept this. Very basic thing I have told. Okay? Now, I am taking 3 points. This kind of question comes in the board examination. Be very focused now. Yes. Now what I am going to do, I am going to take 3 points. Point number 1 towards the left of the plate. Point number 2 between the plate, anywhere, not center, anywhere. Point number 3 towards the right of the plates. Okay. My aim is to find electric field at 1, electric field at 2 and electric field at 3. Okay. Now, first of all, at this point 1, let me draw a point here, 1. At this point 1, because of the positively charged plate, the electric field will be in this direction. Let me name it as EA, because plate A and plate B. And is negatively charged plate, it will be in this direction, EB. Do you agree with me? At this point, because of this plate, electric field will be this direction. How much? EA. And this plate, the electric field will be towards it. How much? EB. What is the value of EA? Just now you have derived sigma by 2 epsilon naught. So, sigma by 2 epsilon naught. What is EB? Sigma by 2 epsilon. Opposite direction.
Minus sigma by 2 epsilon.
Minus you should not put in vector quantities here, because they are vector quantities. You can put minus if you want to put, but I don't prefer to put minus. If you put minus, then you have to add them and make it 0. If I don't put minus, I will say opposite direction. Net field at 1 will become EA
0
minus EB, which is going to be 0. Do you agree with me? Do you agree with me? So, when I made 2 plates, one positively charged plate, one negatively charged plate, outside electric field 0. Now, let us see point 3. I will come to 2 later. Point 3, suppose I am taking a point here, because of the A plate outside, because of B plate towards this side, same logic will apply here. EA will become equal to sigma by 2 epsilon naught, EB will become equal to sigma by 2 epsilon naught, E3 will become equal to EA minus EB, which is going to give you 0. Now let us talk about the most important point, which is E2, between the plates. What is going to happen? Take a point here, positively charged plate, this direction EA. Negative plate, same direction EB. EA and EB are in same direction. Net electric field at 2 will become equal to EA plus EB. EA is how much? Sigma by 2 epsilon naught. EB is how much? Sigma by 2 epsilon naught. What will be that? Sigma by epsilon naught. There are 3 Sarvanans showing, man. Who is the third Sarvanan? Hey. Sarvanan. No, 3 different faces also showing to me. Or one Sarvanan got stuck, I think, there. Sarvanan, yeah, fine. Now it is fine. I think from Velamal, you joined with 2 devices, right?
No, sir.
Okay, so no problem. We don't have time for this. Fine. So is it clear to you what I have done now? What I did now, I took 2 plates, one plate positively charged, another plate negatively charged. Outside the plates, electric field was 0. Between the plates, electric field is sigma by epsilon naught. That is how you create uniform electric field. Actually, we will learn next chapter. This is called as capacitor. 2 plates, one positive charged plate, one negative charged plate forms a capacitor. Leave that topic now. But now understand, whenever you have a requirement of creating uniform electric field, what you will do? take two plates having same charge density but opposite polarity. What will be the electric field inside them? Sigma by epsilon. These things should be there in your head here. It is the conceptual learning, just not mugging up the formula. If you have understood this, copy fast and I'll give another question to you. Make it fast. Don't take much time, please, fast.
Done, sir.
So what we must do.
Shall I? Make it fast. Shall I proceed? All of you have done this? You can do without my help also. A simple thing this is. Now what I want you to do, take a plate, positively charged plate, take another plate, same positively charged plate, and find and tell me what is the electric field here, what is the electric field here, what is the electric field here, fast. This is plus sigma, this is also plus sigma, plate number A, plate labeled B. Find the electric field at 1, 2 and 3. Make it fast. Yeah, Abhinand, I understood you have done. So, yes, as you are thinking, it is correct. Common sense, right? At second point, here and here, same value. At first point, it will be added. At second point, once again added. Isn't it? So, when you solve it, you will understand that outside it became sigma by epsilon naught. This side became sigma by epsilon naught. And here it became. Anybody has doubt in this? Anybody has doubt? Except Vigneshwaran. Anybody has doubt? If no, then imagine if the question would have been negatively charged plate, negatively charged plate. Point 1, 2, 3. What will be your answer? Same answer. Then how they are different?
Same. The charges.
Charges are different. Direction of electric field will be different. Here the electric field will be in this direction. Here it will be in this direction. In this case it will be in this direction and this direction. Do you agree with me? And in the derivation that we made in the class, electric field here, sigma epsilon, which direction? From positive to negative, isn't it? It means that if you have one positively charged plate and another negatively charged plate, then you are going to have electric field. How? It is going to be like this. And what will be its value? Put it in your permanent memory, because this is going to be used many times in 12th. If there are two plates, positively charged plate, negatively charged plate having same charge densities and opposite polarity, then between them electric field is uniform, its value is sigma by epsilon naught. One last question to everybody. If I have a plate plus sigma 1, I have another plate minus sigma 2. That means they have opposite polarity and different charge density. Then you have to find what is the electric field at 1, what is the electric field at 2, what is the electric field at 3. I hope everybody agrees that it will not be 0 anywhere. It will have values here also, here also, here also. You solve this and bring it to me in the next class. It's a homework, not doing now. This question also has come in a board exam in the past. Sigma 1 plus sigma 1 minus sigma 1, you have to find the electric field at 1, that is E1, and you have to find E2, and you have to find E3. Clear? The question is clear to you? You will solve it, get the derivation and show it to me in the next class, okay? Or I will ask ma'am to check, LML ma'am to check in the next Tuesday's class, whatever it may be. Now, let us go to the last topic of this chapter. Now you can start taking notes, okay? Last topic. Which class or school's classwork?
Sir, because I forgot to bring notes.
Nothing you have now. Listen. So now what we are going to learn? Now we are going to learn electric field due to charged spherical shell. So by using Gauss law and by learning the concepts of electric flux, now what we are going to derive? We are going to derive the amount of electric field produced if you have a charged spherical shell. Understand, I am not saying the word sphere. Shell I am saying. Shell is different from solid sphere. Hollow from inside, like a football, right?
Yeah.
We have a, immediately said yeah. So when I say football, immediately remembered Liverpool and Barcelona. Okay, coming back, Abhinand. So we have a shell, charged spherical shell, and this charged spherical shell, I am interested in finding what is the electric field at 3 points. 1 point outside the shell, second point on the shell, and third point inside the shell. Since it is charged spherical shell, I am putting some charge. Again, you can put negative also, you can put positive also, completely your wish. The difference will be, if I am putting positive charge, it will be radially outward. If it is negative charge, it will be inward. That's all will be the difference. So how the electric field direction will be? Like this. Do you agree with me? Like a sun.
Yes, sir. Yes, sir.
SUN, sun. Okay, like a sun, it is having electric field radially outwards. And as I said to you, now what I am going to do? I am going to find the electric field at this point 1 first. What we should do? Gaussian surface has to be drawn. Simple. Already it is sphere. I will prefer a spherical Gaussian surface. On the, what on the? Spherical Gaussian surface I am considering because my aim of Gaussian surface is to cover the charges. It covered the charges, and I am taking the radius of that Gaussian surface same as the distance of the point where we are finding electric field from the center of the sphere. Shweta Shinde woke up? Saw the small dream, no? So what I am saying, repeating for you, listen again. I am drawing a Gaussian surface keeping the radius as the distance of the point where we are finding electric field from the center of the sphere. Okay? And I am taking small r as the radius of the spherical shell. Are you clear? Small r is radius of spherical shell. Capital R is distance of the point where we are finding the electric field from the center of the sphere, or can it be also said as radius of the Gaussian surface, isn't it? Both ways I can say, both are same only. Clear? Now, first thing first, we have to find electric flux. So at this point, electric field direction like this, area vector in same direction, angle between them 0 degree. So flux will become equal to E A cos 0. Do you agree with me? E, let it be like E itself, and A will be 4 pi r square. Do you agree? And cos 0 is 1. Do you agree? This is equation number 1. I hope everybody knows that area of sphere is 4 pi r square, isn't it? Leah Varshini, you will also wait after the class gets over, okay?
Yes, sir.
Yes. So E into 4 pi r square, cos 0 is 1. Is it clear to you what I have done? Next, see whatever I am doing is for point A, okay? Point 1. Whatever I am deriving is for point 1. Then I will go to point 2, then I will go to point 3. As per Gauss law, we know that flux is equal to net charge by epsilon naught. Don't think it is sphere, so it is having volume charge density. No. Though it is sphere, it is having surface charge density only. The charge is not spread in the entire sphere. It is only on the surface of the sphere. So it is surface charge density, isn't it? So what will be Q net? Q net will become equal to sigma into A divided by epsilon. This is the point where students are doing mistake. What mistake they are doing? 4 pi r square. Which r should be taken here? Capital R. How here? Small r. Because Q net we are finding for this shell only, no? And this shell's radius is small r, isn't it? Do a mistake like this, lose marks. This is equation number 2. Now from 1 and 2, yes, from 1 and 2, what you are going to get? E into 4 pi capital R square is equal to sigma into 4 pi small r square divided by epsilon naught. Do you agree with me? Let me use some capital E, some of you are confusing, yeah. So here 4 pi gets cancelled, and I am going to get the expression of electric field as sigma by epsilon naught into r square by r square. Do you agree with me? This is the electric field at point 1, not surface, at a distance r away from the center of the sphere. Now, I can further simplify if I want to simplify. You know how? Shall I simplify? I will simplify. Please pay attention. E1 can be written as, what is sigma? Q by A. So I am writing Q divided by epsilon naught is there, r square is there, capital R square is there, and A. A will be how much? 4 pi small r square. Do you agree with me?
Small r square.
Small r square gets cancelled. E1 will become equal to 1 by 4 pi epsilon naught into Q by r square. Actually, it is E1 is equal to KQ by r square. What is the meaning of this, man? What is the meaning of this? I'll tell what is the meaning of this. I'll tell. I'll tell, listen. Charge spread over the spherical shell behaves as if the whole charge is concentrated at the center of the sphere. Because same charge q, if I would have kept in the center like this, and if I would have gone same r distance away, what is the electric field value here? Kq by r square. Same thing I got or not? This question has come 3 years back in the board examination. Prove that charge on a spherical shell behaves as if it was concentrated at the center of the sphere. 90% student of India will not answer this question and come back. What is this question? I don't understanding. They will say like, never learned this topic itself, sir. But what they are asking, this derivation they are asking. They will not say derivation as find the electric field due to a charged spherical shell at the point outside the sphere. They will not say like that. What they will say, prove that charges spread over the spherical shell behaves as if it is concentrated in the center of the sphere. Is it clear to you how to prove it? So we will do this derivation and we will write, if the same charge q is kept in the center and you go r distance away, the value of electric field is same kq by r square only. So the charged spherical shell distribution of charge behaves as if it is concentrated at the center of the sphere. If it is clear to you, please copy fast. Yes, please tell me, Deva.
So why are we considering capital R in the first electric case?
Yes, you are talking about this, right?
Yes.
Yes. What we are doing, when you are finding the flux due to the electric field and area, what is the formula? EA cos theta, right, Deva?
Yes, sir.
There the area is what? Area of the Gaussian surface. So Gaussian surface area will become 4 pi capital R square, isn't it?
Okay.
That's why I take 4 pi R square here.
Okay.
Let me know when you are done. Good. Okay.
Completed, sir.
Fine.
No, finish for second one, sir.
What, Abhinand?
Finish the second one too, sir.
Yeah, second one you would have put the value of small r and capital R as same, right? So it will become sigma by epsilon naught or kq by small r square.
Yeah.
Yeah, correct. Obviously correct. Common sense, that is. If the point comes to this point 2, which is at the surface, capital R becomes small r. So this will become kq by small r square, or here it will become r square by r square, which will become 1. I am going to write that in next page. So I am going to next page. So what we came to know in this derivation, if you have a charged spherical shell and if you are going at a point which is from the center r distance away, then here the value of electric field is sigma by epsilon naught into r square by r square, where what is small r? Don't confuse in this.
Radius of the sphere, sir, or sphere.
Yes, you can rejoin, Pratap, no problem. Yes, small r is radius of spherical shell. Radius of spherical shell, and capital R is radius of Gaussian surface. Gaussian surface, or I can also take this as distance from the center of the sphere to the point where electric field is found. Am I right? This is the value of E, or it can also be written as, after derivation we got, it can be written as K into Q by capital R square. This we derived in the previous derivation. I am taking this point as point 1, so I am writing E1 here. Now, if I am talking about the point 2, which is lying on the surface of the spherical shell, then what will happen at point E2? Yes, sigma epsilon will become equal to sigma epsilon into r square by r square, because capital R becomes equal to small r here. This 2 gets cancelled, finally we are going to get sigma by epsilon naught. And what about E2? One more way, k into small q by small r square. Is it clear to you? Okay, what about third point? Third point lies inside the spherical shell. What will happen? When you draw Gaussian surface, how much charge is enclosed? 0, right? Only if the Gaussian surface is outside or on the surface, charge is enclosed. If I am going inside the spherical shell and there is no charge enclosed, cannot I conveniently say that E3 will become equal to 0? Why? Since no charge enclosed, there is no charge, where is the quotient of flux? Where is the quotient of electric field? Are you getting my point? So for a charged spherical shell, outside the shell, the value is sigma by epsilon naught into r square by r square is equal to kq by r square. On the shell, sigma by epsilon naught or kq by r square. Inside the shell, 0.
Sir,
Yes, please ask me, Deva.
sir, what if the charge is placed at the center of the...
Then it will not be 0. If the charge is in the center of the shell, then the value of electric field will be kq by r square. And what is this r value? Based upon that.
Okay.
Okay. Have you copied this? Make it fast, all of you, those who are writing. Shall I? If you permit me.
Yes, sir.
Yes. Now I am going to draw a graph. This graph is once again very important for the board examination. This graph is between electric field and R, which is the distance. R is distance. Okay. Until the distance becomes radius, electric field is going to be 0, isn't it? and then the electric field value is going to be maximum, and as you go away, the electric field is going to reduce. Am I right? Why I am drawing this graph? Why not a straight line? Because electric field is inversely proportional to square of radius, right? So it will be parabolic curve only. I hope you are getting my point. If they ask you in the examination, draw the graph showing the variation of electric field for a charged spherical shell. This is the graph. And here r is what? Radius. Small r is radius. Are you getting a point? Which shows that till the r becomes radius, electric field is 0. The moment the r becomes radius, electric field is maximum, kq by r square, and then as you go away, electric field starts to reduce. Is it clear to you? Sure?
Yes, sir.
If yes, then let me take one question from NCERT. Anybody is there who don't have NCERT book? Book means not in the classroom.
No, yes, sir.
Okay. Then I'll open in the screen also. And you, if you have the NCERT book, come to page number 36, example 1.12, the very good example. Don't see the answer. Challenging question. That is very challenging question. I'll open the book for the people who are not having the book. I am repeating, please don't look into the answer. It's a very interesting question.
Okay.
Little complicated. So try to do it by yourself. Because this is a question from volume charge distribution, which is not there in syllabus literally. I mean about the using Gaussian law. Rho is there in syllabus, but not as a concept. But they have asked a question here where you have to use volume charge density concept, isn't it? Think for a while, you'll understand. Again, this question has come in the past paper of board examination. An early model of an atom considered it to have a positively charged point nucleus of charge Ze surrounded by uniform density of negative charge up to radius r. The atom as a whole is neutral. Obviously, everybody knows this. This is an old Thomson's model, maybe earlier model, not the Rutherford model or something. We know electrons are moving in orbits. Some old model, that's why an early model they have told. So the atom as a whole is neutral. For this model, what is the electric field at a distance r from the nucleus? Distance r. So r,
No.
yes.
They given small r, sir. That's what we have to find. Electric field at distance small r.
Yes. Small r means you should say maybe if the r is here or r is outside or r is on the surface. Everywhere you should find. Same like.
Oh, okay. Right, right.
Can you think about it? If you see the answer also, you won't understand. So try to figure it by yourself. I will help you. Good question.
Like R1, R2, R3, sir. That R1, R2, R3.
You are saying the values. What are you asking?
No, they asked find R, sir.
They're asking us to find electric field, not R.
Yeah, that's what I'm saying. What should we take as the R?
R
Is it outside the sphere?
yeah, you take outside also and solve. Take it as inside also and solve. Outside, what will be the value? Tell me it now itself. Outside will be what? 0, right? Why 0?
Yeah,
Because the atom is
because
Atom is
it's
neutral. Neutral atom. Exactly. Very good.
Yeah,
So the only worry is inside. Isn't it? Think about it. And if I am right, they have taken 2 points of R. One is outside the nucleus and one is on the surface. If I am able to feel it. The way they have drawn the diagram, there are 2 R drawn. One R is drawn on the surface of the atom and one R is drawn away outside the nucleus. Think about it. Yeah, yeah, take time. I take 5 minutes, no problem. But try. Otherwise, I am going to solve at the last. But not as how the book has solved. I will try by my own way. Okay, Saravanan, you can be back. Blessing Saravanan, okay? Not Velaman Saravanan. Shall I help you? This question is little challenging. I am not denying that. I am not saying easy question. It's challenging question where you have to think something about volume, charge, density also. I'll tell you why you have to think about that. Okay. Now please pay attention. I am going to solve the question. I need some space, so yeah, I think this will be sufficient hopefully. Okay. Now please pay attention what I am doing. I will give time for writing anything you want to write. Please pay attention, understand the concept, what is going to happen here. So they have drawn, actually 2 points they have drawn. One point is outside and one point is here. Because what is the value outside? Same is the value on the circumference. See, when you take the point outside and you draw a Gaussian surface, then what is the charge enclosed? First of all, understand, if you have an atom, in the nucleus, suppose Z protons are there, that is the number of protons only. So charge of each proton is E, small e. So total charge inside the nucleus will be how much? Ze. Do you agree? And total charge of the electron will be how much? Minus Ze. Do you agree? So Ze plus Ze is the total charge of positive, minus Ze is total negative charge. So what is the Q net? Q net will become equal to plus Ze minus Ze, which is going to be 0. If net charge is 0, net electric field will obviously be 0 for outside point. It's done, simple. Outside point, or even on the surface you can say same thing will be happening, plus Ze minus Ze 0. Challenge is, what will happen at a point somewhere here where the charge is non-zero, it's not 0. But one thing is very clear, if you want to find the net charge for this second case, the net charge will become equal to plus Ze minus some charge here.
Some fraction of
Negative charge. Q because of negative. Now challenge is to find that Q. And how do you find that Q? How do you find that negative charge? I'll say about that. What is rho? Volume. So for the entire sphere, that is for, I can write rho is, here I can write is equal to Q by 4 pi r cube. Can I say like this? One second, I'll erase this.
4 by 3 pi r cube.
Obviously 4 by 3, sorry. 4 by 3 pi r cube is the volume charge density of this shell. Do you agree with me? Do you agree with me? Now, can I say that this charge Q, or I can say one more way of saying, easy way I will use, not to complicate things. For 4 by 3 pi r cube, the charge is Q. Unitary method. Then for unit volume, charge will be Q by 4 by 3 pi r cube. And for this volume, 4 by 3 pi r cube, the charge will be Q by 4 by 3 pi r cube multiplied by 4 by 3 pi r cube. What I am doing, you are understanding? What I am doing is, if 20 bananas are costing 100 rupees, what is the cost of 4 bananas? This question comes. 20 banana, 100 rupees. What is the cost of 4 banana? How do you solve this in 6th class? 20 banana, 100 rupees. So 1 banana is 100 by 20, which is 5 rupees. So 4 banana is 5 into 4, which is equal to 20 rupees. Am I right? Same thing I am doing. What I am doing? For the full volume, charge is Q. For unit volume, charge is Q by this. And for 4 by 3 pi, this volume 4 by 3 pi r cube, the charge will be, I am talking negative charge alone. I am talking about negative charge alone. It will be q by this into this 4 by 3 pi, 4 by 3 pi gets cancelled. And you get the value of negative charge. I am only talking about negative charge. Please understand that. So negative q will become equal to q times r cube by r cube. Do you agree with me? Do you agree with me? Then what I am going to do? I am going to put this q here. I am going to get q net. So step 1 remains same. Step 1 will be finding the phi, which will become equal to Ea cos theta. Theta will be once again 0 here. So E into A. A will be how much? 4 by 3. I will do it. E into, not 4 by 3, 4 pi r square, isn't it? Equation number 1 for finding phi. Then I will find Gauss law. Phi will become equal to q net, which you are finding now, divided by epsilon naught. Then I will equate both, and then I will subtract. When I equate both, I will get the value of electric field, isn't it? What is the value of q net? Q net will become equal to Ze minus qr cube by r cube, isn't it?
Yes.
So we'll put, tell me, man.
Sir, why don't we take volume density, sir?
Because here the charge is not spread on the wire or not spread on the surface, it is spread in the volume. You can imagine the atom, right? The atom center part is positive and around it, it is negative. It's shown in this model. So here the charge is spread in the volume, not on the surface. That's why we are using volume charge density concept. Understood?
Yes,
This level of question actually comes in JE, not in school. Rarely comes in school. Like this year Delhi paper, something that is can come. This year Delhi paper was very tough for physics here. 40-30% questions are from JE level. South India was little easy paper. That itself they are crying, telling very tough paper this time. Delhi paper if you see, and then you will realize how the question paper was. But anyhow, not to fear you, but this level of question generally don't come in the examination, but yeah, it may come in some tough paper. But not very difficult to understand if you are clear in what I have told now. What I have done, I have found the negative charge here. How I have found negative charge? By using unitary method. For full volume, this much negative charge. Ze actually. What is Q actually? Here I can, like this also I can write. If you want me to, I will write like this. Wait. For make it little simple for you, I will write it here without, instead of writing Q, let me write for the full thing, it is minus Ze, right? And for this thing it will be minus Ze by this. For this one it will be minus Ze by this. You will have some kind of faith. It is going to be little easy now. Yeah. So it is going to become minus Ze into r cube by r cube, right? Then when I put it here, I am going to get q net is equal to Ze minus Ze into r cube by r cube. So I am going to get Ze common. In bracket it will be 1 minus r cube by r cube. And if I find phi, it will become equal to Ze by epsilon naught into 1 minus r cube by r cube. Equate both, you will get the answer. So when I equate both, I don't.
Equate E4 pi r square, that one.
Yes, obviously, this one.
Okay, fine.
This one you have to
Yeah.
equate with this one.
That one, yeah. 1 and 2. Okay.
Yes. So 4 pi r square, it will go this side and it will give the expression of that final electric field. Is it clear to you? I accept this question is little complicated, but not impossible kind of question, simple question only, if your concepts are clear. Fine. Any problem in this question?
So, like, can
Yes.
you repeat this again, sir? This question.
Once again, you are asking me to tell you.
Yes, sir.
I will do it, and I will take my board. It is like looking very complex here. Too much happened in the board. So what I am going to do, I am going to draw a atom where center is positively charged, okay, Shaktivel, and then I am having negative charge distribution like this, right? What I am going to do, my aim is to find what is the electric field r distance away from the center. From here I am going r distance away, and I am going to find what is the electric field. For that I am going to use Gauss law. So first understand that if I am using Gauss law, I have to take a Gaussian surface, and this Gaussian surface, how much charge it is enclosing I should know, right Shaktivel? So if it is the entire sphere, I can say plus ZE minus ZE, zero charge. But if it is a given particular volume, then the charge will be how much? Plus ZE minus something, which is, I don't know, value, I am writing it as Q. So first I want to find the value of Q, how much is the Q is. So for that what I told, I said that for the whole sphere, for 4 by 3 pi r cube, the value of charge is ZE. Then for unit volume, the charge will become equal to ZE by 4 by 3 pi r cube. Shaktivel, I hope you are listening.
Yes, sir.
And for this volume, which volume? This volume will be 4 by 3 pi r cube. The charge will be how much? ZE by 4 by 3 pi r cube into 4 by 3 pi r cube. 4 by 3 pi gets cancelled, and you are going to get ZE into r cube by r cube, right?
Yes, sir.
Now this is the value of charge. I am going to put it here. So I am going to get net charge Q net as ZE minus ZE divided by r cube by r cube, right Shaktivel?
Yes, sir.
Then ZE, if I take common, it will become 1 minus r cube by r cube, right? Now I have to use Gauss law. So when I am using Gauss law says phi is equal to Q net by epsilon naught. So phi will become equal to, what is Q net? Q net we have found, it is ZE by 1 minus r cube by r cube. So ZE 1 minus r cube by epsilon naught. Also phi is equal to EA cos theta, isn't it? So phi will become equal to E. What is A? A is 4 pi small r square, cos 0 is 1. Now equation number 1, equation number 2, I will equate both. I will get E into 4 pi r square is equal to ZE divided by epsilon naught into 1 minus r cube by r cube. So E will become equal to ZE divided by 4 pi r square into 1 minus r cube by r cube. Okay, write epsilon naught also. Who has stopped you? So I can write E is equal to K ZE by r square. Shall I send inside? Then it will become, I am sending inside, right?
1 minus r cube. Sir, no need, sir. Leave it. No need.
No, I am writing like this. I will make it easy. R cube minus r cube by r cube into r square. No, don't wonder it. Tension only, yes. So if I divide each term, it will become E is equal to K ZE into, this will get cancelled, so it will become 1 by r square minus, in this case, it will become r by r cube. Yogit? Basic mathematics, man, not some hi-fi logarithm or differentiation I am doing. Multiplying, dividing only I am doing. Okay. Yashwant, what you need? Zandu Bam? Huh? Iodex, what you need?
Sir,
Huh.
the last step of the previous page.
Yeah. Any problem in this? If you have understood it, then this chapter is done. I am giving a small work to you. Why I am saying small work? Because if you are following whatever I am saying from the beginning, it is small work only. Before Tuesday, you have to finish NCERT full exercise and full example. 13 examples are there, and how many exercises is there? 20? I don't know, let us verify. 22? 23. 23 plus 13, it is 36. If you have not done anything till now. If you have done already something, then it is there. I will ask LMLU ma'am to check your notebook on coming Tuesday. I'll ask her to check your notes also and put sign in your notes. Is it clear to everybody? Please finish and come. All your doubts ask from ma'am, make it clear. Before we start second chapter, we should thoroughly close first chapter. Fine? Any problem? No? Everything's clear up to here? I hope it is. Right? Huh. I will. Yes. If somebody is writing something, please. Done. Can I go to the next thing? Question number 1.21, exercise 1.21, those who have book in their hand. I will display the question on the board also. Question number 1.21, very simple question, do it now. 1.21 from NCERT textbook. 1.21. I will display on the board shortly. Shall I display the question? Previous slide. This you can copy little later, man. I'll not going to erase this. Okay. Let me display the question also. I'll give time for copying. Don't worry. I asked 1.21. This question. Sigma is given, diameter is given. Simple question here. They are asking to find charge. Sigma is equal to Q by A. Oh my god, this kind of simple question. So Q will become equal to sigma into A. Sigma is known to you, A is known to you, multiply and find charge. And flux they are asking to find. Flux will become equal to whatever charge you find divided by epsilon naught over. Simple question. I am taking the attendance, please. So, if your name is called, please say yes or no, okay? Aditya Raj, Anshul is absent. Badri, Farzana, Harvish, Kailash is Kavya. Kavya is absent. Yeah, present, right? Kirti, Leah Varshini,
Yes, sir.
Mrityunjay, Devadarshan,
Yes, sir.
Nikhil, Niranjan, Pavitra,
Yes, sir.
Pratap,
Yes, sir.
Akshaya, Mithun,
Sir.
Shaktivel,
Yes, sir.
Sarvanan. Now, Sarvanan, there are two. One second. This Sarvanan, what is registered here is Blessing Sarvanan, whose video is off. Velamal Sarvanan, you have to register yourself. So, anyhow, you are going to wait now. So, Sharan Ram is there. Shweta Shande both are here. Vaishnavan is absent. Varshita Shri is absent. Yash Pravin is there. Yashwant is there. Yogit is there. And Yuva Shri is there, right? Whose name I not took now? Your name I not took? You are not registered yet. Your name is not there. Dishita. I not took your name? I registered there, yes. I will check that. So, Dishita name I have retaken, Sarvanan and Vigneshwaran. Anybody else whose name I have not taken? Anybody else? Yeah, Nitish Raghav name I have not taken. Yeah, you are not saying.
Yes, sir.
Yeah. And anybody from here? Nobody, right? Rest every name I have taken. So, Dishita, you are saying you have registered yourself. Filled that form you have filled, right? So, form filling is remaining for this Velamal Sarvanan, Vigneshwaran and Nitish Raghav. Nitish Raghav, are you aware about the form? No, right?
Sir.
Are you aware about a form?
No, sir.
Okay, I will share a form in a group today. Please fill it immediately after the class gets over. Today itself fill the form. Then only you will be registered in the app where you will be getting the attendance and all the access, okay?
Okay, sir.
Fine. Same way even you will fill the form. And Saravanan, you will also fill the form. Velamal Saravanan. Yes, got the answer? You know, not filled the form you are saying. But yes, we do from last year data. But you also fill the form, please. Got the answer? Flux not found.
Yes, sir.
What is there in flux, man? They're over. Once you got Q, what is there in that? Sigma is equal to Q by A, isn't it? Since sigma is equal to Q by A, Q will become equal to sigma into A. Sigma is given as 80 microcoulomb. 80 into 10 to the power minus 6 coulomb per meter square. Multiplied by, what is the area? Area is diameter is given, so half of that, 1.2. So 4 into 3.14 into 1.2 square. When you solve, you will get the value of charge. Into minus? Is it same for everybody? If it is right, then it is the value of Q, and phi will become equal to this value divided by epsilon naught. So see, now you will have some lengthier calculations like this only. But it is simple. Anybody has doubt in this question? I don't think it should be there, right? So, towards the end of this question, once again I am repeating, towards the end of this question, this chapter, before you start the next chapter, which will start on Wednesday, you need to be strong in the first chapter, because second chapter has direct link with the first chapter. I am going to start my class with the concept of electric potential, potential difference, potential due to a dipole, potential due to a charged spherical shell. All these things I will teach in the next class itself. So, if you are not knowing this thing well, you will definitely have problem in the upcoming class also. So, make sure that you are strong and you are understanding this concepts whatever I have taught till now. Okay. So, we will finish with today's class. If anybody has to ask any doubt, they can stay back, others can drop, others can leave. Saravanan and Nitish Raghav, please stay back, don't leave. Saravanan means Velamal Saravanan. Okay. Others can leave, others can drop, or if somebody has some doubt, you can stop. I don't have any problem. If anybody has any doubt, you can stop.
Sir,
Yes, Pratap.
as for exams are going, I will try my best to complete all the exercises and ask doubts. But,
Okay.
After my exams are all, can I come and meet you center?
Yes, yes, you can.
Okay, sir. Thank you.
You come a little this side.